Hi everyone, welcome to Zero to Snowflake in 58 minutes. This is a pre-recorded session. In this session, Junior Data Engineer Sal is going to walk through Snowflake's Getting Started guide and show all of the core features of Snowflake. So this will be a great session for anyone who is considering Snowflake as part of their technology stack, or for new users of Snowflake, or anyone who is just curious about all the hype around Snowflake. The link to Snowflake's Getting Started guide will be in the description. And this session will be available on demand after we're done. So if you'd like to use that guide and look back at the video for guidance, you can absolutely do that. And if you like what you see and you'd like some help implementing Snowflake or migrating to Snowflake or sharing data, please email us at sales@datalytics.com. And without further ado, here is Sal.
Hello. In this video, I will go through the steps of getting started with Snowflake, Zero to Snowflake module, to explore some of the steps and environment of the Snowflake. So the first step is to sign up for the free trial using the email address and also choosing what kind of Snowflake edition you want, cloud provider, and the region. Now, even though at the beginning of this module, it says that it doesn't matter what kind of cloud provider you choose and what kind of region you choose, actually, from my own experience, it does. For the purposes of this video, Amazon Web Services is chosen and London is chosen as the region, since some of the publicly datasets are not available in Microsoft Azure Cloud. But other than that, everything should be fine. So once we sign up for the Snowflake and we log in with our credentials, this is the user interface that we are facing. And I will go through the Hire tab one by one and with what each of these icons, little icons, represent. So at first, on the left-hand side, we see the databases icon. And if we click it, we are directed into the database section. So this tab just shows information about the databases that I have as a user created or I have permission to access to. In here, there are many things can be done. So you can, for example, create a new database from here. You can clone a database, you can drop the database, and you can give an ownership to some other user. Also starting from here. Now, when we sign up for the Snowflake, there are already three demo databases that exist. And these are just like simple practice. Whenever the user wants to practice, it's a really good way to get started and sort of play around with Snowflake. The next icon is the shares icon. And in the shares tab, here, as a user, you can share different Snowflake tables with other Snowflake accounts or the external users without having to create a copy of the data. Then we have the data marketplace, and this is where a user can go and explore other publicly available data sets, which can be about COVID, can be finance, anything really that's out there sort of, and not only publicly available, but also some of the data sets might have a price, or some of them just need to be requested. And then the producer of the data set will contact you directly and maybe will give you the permission to access the data, or maybe won't give you permission. So this is a great way to add some more insights to your analysis if you're lacking the data, or if you want to check or receive some of the more external data, which can be helpful for your analysis. The next tab is called the Warehouse tab, and this is where you set up and manage the compute resources, which are virtual warehouses and where you load and query data in the Snowflake. The Snowflake comes with already compute warehouse included, which is the warehouse that's already included in the account in the free trial period, at least. Then we have the worksheets, and worksheets is sort of where everything happens. This provides an interface for submitting the SQL queries, and performing various DDL and DML operations. And here we include our queries in this particular section, and then we see the results of our queries below. And on the left-hand side, we see basically everything that has been sort of created. All the databases and the schemas that have been created by us or already exist in the data warehouse we can access from the left hand panel. And also we can check the performance of our queries using this little arrow over here, which we will see later on in a with a better example. And then finally we have the history tab. And this history tab provides details of all queries executed in the past 14 days from the Snowflake account. And then finally, on the very, very right-hand side, we see this particular sort of like panel where we get to choose we see the information about our account. So the username, what is the role, we can change the password, log out, and switch the roles, which will come sort of like later on. This particular module uses a data set, a sample data set, which is a city bike data set, which is the real citywide bike sharing system in the USA. And the idea of the sample lab is to analyze sort of the data or run analytics on the data to better understand their riders and how to best serve them. So the first step to go on sort of with the data is to start with the database. So we have to create a database. To do this, we go onto the database icon and we press the button and we see the following, again, like we saw before, the following picture. So to create a new database, we simply have to press the create button. And first we need to include the name. So the name of this particular database will be City Bike. And to create this, we simply have to press finish. And the database is completed or is created. Now we can go to the worksheets. And here we can start working sort of various things in this database, and we can actually start working in the database from the worksheet, since worksheet is where we complete and where we submit some of the queries that is already stated. However, before you start working on your worksheet, you have to make sure that you are in the right environment and the context of your working is correct. And to do this, we have to check this panel right over here. So in this particular case, what we have to see is that what is the role that we are working with, and in this particular case is the system administrator, which is correct, and we're going to leave it. What is the warehouse that we are working in? And we only have one warehouse at the moment, so it is the compute warehouse. We need to choose the database. So there are multiple databases, as we already saw, but we want to use the database we just created. So this will be the City Bike, and then the schema will just be public. So it is publicly sort of available, whatever we are doing. So now the context is set, everything is correct here. So we can actually start working on our database. So for this particular module, the SQL queries are already provided, and just to make things faster, some of the big queries I also have sort of copied and pasted. I'll just using them. I'll just copying and pasting them, so it's easier and faster to see. So the first step is we have to create a new table, which will be called trips. And this table will be used for loading the comma delimited data. So within this query, we are telling sort of the data type that we want. So for example, for trip duration, we want integer. For start time, we want timestamp, and etc. So we are creating some sort of a schema for our table. And then we execute this query. And we see that the table trips was successfully created. So this is the results panel that we talked about before, where we can see whatever it is that required to our SQL, it was successful or was not successful or not. To check that this table was indeed successfully created, we can go to databases again. We can go into the City Bike, and we see indeed that there is a table called trips. And if we press these trips, we do see indeed that whatever it is that we included, the type, the data type, for example, right? So the start station latitude is the float. We see that everything is correct and everything seems to work perfect. So then the next step is we want to actually access the data, and this particular data, the city bike data, is provided in the S3 Amazon Web Services bucket. So to do this, we need to create an external stage that will specify the location of the external bucket. So to do this, we go back to the database icon, and here we have multiple sort of choices or options that we can create. So we can have views, schemas, stages, file formats, sequences, and pipes. As I already said, we need to create a stage. So we're just going to go to the stages part here. And to create a new stage, we simply press this button, create, and then we have various options to choose from. As I already said, it will be in the S3 bucket. So we just choose the Amazon Web Services and we press the next. And now here again, we have to choose some of the, or we have to input some of the credentials for this particular case. So this stage will be called City Bike Trips. It is the public schema, and then we need to include sort of, we need to input the URL where we are accessing this bucket. So this workshop lab city bike trips is the address, and this one needs to be free because this is public, so we don't need to have any AWS key ID or the secret key. So once we are done, we just press the finish. It is processing, and now we see that we have already created a new stage. So to see how does this work, we go to the worksheets again, and here we can see, we can sort of check the contents of the city bike trips. And to do this, we just simply do list city bike trips, and we execute this code. And here in the results tab, we are given the following result. So we see the name of the bucket, we see the size of it, and sort of when was it last modified. So now, even though we've already checked the contents and we've created a new stage, we need to create a file format that will match the data structure. So we are actually, this enables us to load the data actually into the Snowflake. So to do this, we go back to the database panel and we go to the file formats and we create a new file format. So in this case, we know the type of data is the semi-comet dilated data. So we choose the CSV, we choose the public, and we are told in this tutorial to choose the double quote here, and that to leave this sort of empty, and we uncheck the error on column count mismatch, and we press the finish. And we see that the new file is created for our particular database. Now, the next sort of step explores the warehouses. So the warehouses need the computer power to load the data. Snowflake's compute nodes are called virtual warehouses. And one of the great things about Snowflake is that these warehouses can be virtually and really quickly dynamically sized up according to the workload, depending, like this workload can be loading data, or maybe the query that we are running is very complex or performing a DML operation, or it can be sized down, scaled down, depending again on these three factors. To do this, we go to the warehouses tab, and then we just press like here, not an actual hyperlink, but just like here. And then we can press the configure the warehouse. And this is the window that we get. So what does each of these sort of small box mean? So first we have the size. Now, the size is where we select the capacity of the warehouse. So for larger data loading operations or very complex SQL queries, we need to choose the larger data warehouse because the size translates into the underlying compute nodes. And hence, if you have like a complex or like queries or the bigger loading data, then you need to have a bigger size. So the larger the size, at the same time, the more compute resources from the cloud provider are allocated to the warehouse, and hence it is sort of more expensive and it requires more credits as well. Then we have the clusters. So the clusters is very sort of if you're using a very complex data or if the data set available is like very large, then maybe you can choose like multiple clusters. But when sort of like single warehouse to be like, you can choose a single warehouse to have like a clusters or not. So if it's complicated, then you will choose more clusters. If it's not, you can just choose one. And we can choose maximum up to 10 clusters. The multi-cluster it's ideal for the concurrency scenarios, such as many business analysts, for example, when they're simultaneously running different queries at the same using the same warehouse. Then they can sort of the various queries can be allocated across multiple clusters to ensure that they run quickly. So the overall performance, because so many users are doing exactly the same operations, the overall performance will increase and it will be quicker than sort of having to operate only one cluster. But if it's only one user working, for example, in this case, we don't really need a cluster, so we'll just choose one. And then finally, this is the auto resume. So if this box is ticked, this means that the warehouse will be automatically suspended and will stop itself when it's not used. So in this case, we are not spending any credits. If this box is unchecked, then even when you're not running the warehouse, your credits will be going. So you might become broke very soon. So it is always a good idea to make sure that this box is indeed ticked. So in this particular in this particular case, because the data is not very complicated and we're not running very complex queries, we will choose the small size as the capacity of our warehouse, one cluster, and then we just we make sure that we have this particular box ticked, and then we press finish, and we have configured our data warehouse. Now, the next step is to actually load the data, because we have already created the stage for the external bucket. We have already created a table giving it sort of its schema on what each column, meaning like sort of what kind of data type do we have for each column. And we already know the configuration of our data warehouse. So now we can actually go on and load the data into our table. So we go back to the worksheet, which is where sort of all the work is done. But again, before we start working on the worksheet, we have to make sure that we're in the right context, which is done right over here. So again, we check we are in the role of the system administrator. The warehouse is indeed compute warehouse. Database is CityBike and public. So everything seems okay. So now we just go and copy the data. So we load the data using the copy function. So we copy. Oops, sorry. We copy into trips from CityBike trips. We have to specify this file format. So the file format is equal to CSV. And then we run this. And we wait a couple of seconds when the data is loading, because the data is, I think, 64 million rows. So it will take a little bit of time, which is fine. And once it is done, again, we will see the results in the in the results tab right over here. So it's still loading. And it is done. So this is the result that we get. So as you can see, we can see the status, and it says that it's loaded. However, this is here we are also demonstrated what the configuration actually does and how important and how powerful the sizing is. So to check the performance, as I already said, we can see the performance, sort of how long did it take, etc., with this little arrow right over here. So if I press this arrow, what we see is that this particular query, which was copy into the SQL query, which was copy into trips from the city bike trips, which is what we just did, it took 42 seconds. So we see that with the small data size, it took 42 seconds. Now, to prove that sizing actually increases the duration or the performance of the query itself, so it should be faster, we can go here and we can ask the resize for the warehouse, and we can go from the small to the large warehouse. So now we've changed, we resized our data warehouse. And now to check if this actually works, we run the same query again. And it executed already. So it was executed already. And actually, if we compare, so this was the one that we did initially, and this one is the one that we just did. Oh, sorry, actually, it's zero file process because I did not drop the table. Sorry. Before we do this, my bad. So before we run again on the resize to actually see if it worked or not, we can't have the data loaded already, because then it's the same thing. So first, let me do this. Sorry about that. So this was executed successfully. So now we don't have this data loaded anymore. And then we reload the data with the large resized data configuration. And it should be faster than the 42 seconds, hopefully. Yeah, and it is faster. So we did this in approximately 19 seconds. And then the first with the large resized data warehouse, and with the small data warehouse, it took us 42 seconds to get this particular result and load the data. So this was just to show that actually the sizing is really like makes a difference, and then that's why sort of it's more expensive as well, because it uses more compute nodes, and it's much faster. So we can also create our new data warehouse, which is one of the amazing things sort of about Snowflake as well, because maybe you want to create a particular data warehouse, so you can share this with people for the end users who run analytics. So for example, if we wanted to create a new data warehouse only for the analytics people who can come in sort of and look at the data and look at the data and analyze it, then we can just simply create a new data warehouse here, and then process the data there. So we go to the data warehouse, and then we press the create, and the name for this one is analytics warehouse. We choose the large size, and we choose the one cluster at the moment. So everything is ticked here. So we just press the finish, and the new data warehouse is created. So now to check sort of the next section actually explores the analytical queries, results cage, and cloning, which all are very, very important parts of the Snowflake and the Snowflake experience. So we go and check sort of to look at the data that we just loaded. And to do this again, we have to make sure that we're in the right context. So we check that we are in the sysadmin. Now we are working in a different warehouse, because we said that we are an analyst round. We're changing sort of what we're doing. So we go to the analytics warehouse. So we switch the data warehouse from here. So we choose analytics. The database is still the same, city bike, and then we have the public. So we check the data that we just loaded. So we can do this by the simple query of select from trips, and then we limit the first 20 rows. And this is what we see. So now we actually, now we actually see sort of a normal, normal data, something that we would want to see as an analyst, for example, so we can work on it and run some of the analysis and make it useful for insights. So for example, let's imagine that we want to get some of the basic hourly statistics, which I believe is already given in this particular example. So I will just copy and paste this query here. So here, by executing this query, we get hourly statistics. And in particular, what we get for each of the hours, what was the number of the trips, what was the average duration in minutes of each trip, and what was the average distance of these trips. Now, this is actually really important. So if we want to see which hour was more like the busier and sort of which one was well, not so much or not so much busier, and then we can get some of the very good insights for this. However, the reason for this particular query in this particular example, in this module, is that actually Snowflake has a result cache that holds the results of every query executed in the past 24 hours. So whatever it is done in the worksheet, it doesn't matter how far, how complex or easy the particular query is. These results are actually saved for the past. I mean, these results are held for past for the next 24 hours. And these are available across the warehouses. So actually, the results that are returned to one user will also be available to another user. And the best part of it is that whenever the new user comes in and executes the same query, not only the result will be faster because it was already executed. However, also it will not use the compute credit. So basically, for the second user, it's free. So if we want to see this cage sort of in action, so we already executed this code, and if we do execute this again, and so if we go into the history, so just to like check how fast, sort of how fast it was, it took us it took us 1.23 seconds the first time we did it. So this is the first time we did it. And the next time we did it, which was in 2 minutes later, it took us 43 milliseconds. And this is because it was held, the results were held. And so we inquired this particular query. So it was much faster. And frankly, we didn't it didn't cost us any, credits. So now let's, for example, check which month is busiest. I will also get this code, so it's much faster. And when we execute this, we get the following results. So June was the busiest, for example. Now, the next sort of amazing feature of Snowflake is cloning a table. So Snowflake allows you to create clones, which are also called the zero copy clones. And this can be for tables, schemas, and databases. And all of this happens in seconds. The reason why it is called the zero copy is that actually the underlying data is not copied. So only the metadata and pointers to the underlying data change. So the storage requirements are not doubled when the data is cloned, which is very useful. And the clone data itself is very useful because if you want to experiment some of the new things and you don't want to sort of mess with the data, you can just clone a table and then play around with it and use it for development and testing and test it without impacting the production environment. Or without the need to set up and manage these two separate environments. So to do this, we can just execute the following code. So create table, trips, dev, and then we clone the trips. So we are creating the clone of the trips. And then to check that we actually created this, this is a clone, we go to the left-hand side, which I already said shows all the databases, all the schemas and tables created. So we just refresh to make sure that we see the city bike. So we created the city bike database. We press the city bike database, and we know that we are working in public. So we press the public. And what we see here is that we have two tables. The first one is the trips table that we created from the beginning, and then the next one is trips tab, which is the cloned table of the trips. So we do indeed say that we successfully created the clone data. So the next part of the module explores loading and sort of working with the semi-structured structured data views and the join. So in the Snowflake, we can not only input the structured data, but we can also work with the semi-structured and unstructured data. To do this, we create a new database for the new data structure. And before we created the database by using these icons, but actually we can also create a database by simply using the SQL worksheet. So create a new database. We can just write create database weather. Execute this code. And it was successful, I hope. Yes, successfully created. As a next step, we need to make sure that we are in the right context. So before we used to do it by hand from here, we can write the code. So we are using the role of the sysadmin, so the system administrator. We are using the warehouse, which is compute warehouse. We are using the database weather, which is what we just created. And the schema is public. And again, we just execute this code. Perfect. Now we need to create a new table like we did for the trips. But for this one, it will be the weather data. And this is used to load the JSON data. The SQL has a special column type called variant, which is what we are going to write for this, since it's a JSON type data. So create a new table. So we create JSON weather data the variant, and we execute this code. And this was successfully created. So just to check that everything is working, we can go to the database again. And we see we have a new database called weather. And once we go in, we do indeed have a new table called the weather data. Perfect. And the type is the variant, as we said from the beginning. Now we go back to the worksheets and we need to create a new stage. Again, we could do it from here, or we can use the code. So create a new stage for our external data. To do this, we do create stage. So here we put the name of it. In this case, it's the NYC, NYC weather. And then we have to specify the address of this. So this is S3 Snowflake workshop lab weather NYC. And we execute this code. And we see that it was successfully created. And again, like last time, let's check the contents. So list NYC weather. Now this is different from the previous data. This is a JSON file. So when we, sorry, my typo. Let's try again. So here again, we see as previously, this is the result that we want to sort of see. And now we can just start loading the data using the copy function. So we do copy into JSON weather data. We specify from where. So we do it. So we do it from NYC weather. And the file format last time was CSV, and in this case, it is type JSON. And we have status of loaded down here. So let's check the content. So we can do the select from JSON weather data. Let's look at the first 10 rows to see how it was loaded, sort of. And this is what we get because this is a JSON data. So actually, if we press any of this, it's literally the sort of in the row JSON table. So this is not very helpful for the analyst, obviously. So what we have to do is we have to make it more useful and more applicable. So we can use the view function to view this data as a table. And for this, I will just simply copy this because it's quite long and we would just waste time. So we create the JSON weather data as view. Okay, so it's easier to see and to actually see like what's actually happening in the data. And then once we've created this, we can the view comes differently than the table on the left panel. So let me just refresh this panel. So if we go to the weather database and a public, as you can see, the JSON weather data is a table, but then the JSON weather data view, which is what we just created, is a view. It's not a table. And so, for example, to verify the view, now we do the following query, and then to see sort of like how does it look, and we want it to look like a structured data. So it's actually useful for the analyst. We can run this query. So where we want to, when we're accessing the JSON data view and running this query, we get the following data. So it actually looks like structured data, and it's now easy and sort of accessible to work with. So now we have two databases. We have the city bike database, which gives us information about the trips, excuse me, and we have the weather database, which gives us information about the weather. And let's say we want to find some sort of, if there is a relationship or if there's a correlation between the trips and the weather. Now for that, obviously, we need to join these two databases and these two tables to make sure that we can find if there is some sort of a relationship. To do this, we can use this code. So where we are using the left outer join for the JSON weather data view and the trips. So it's the city bike, public trips, from the public trips. So this is what we got. So here we see that actually the most of the, this is in descending. Yes. So here we actually see that the most of the trips, the number of trips we had was in the clear sort of weather, which is no surprise, because obviously people don't want to ride the bikes when it's raining or when it is snowing. So this is how we managed to join the two tables and find the relationship between the number of trips and the weather. Now, another great feature of the Snowflake is what's called the time travel. And so, as we already said, the default window for the Snowflake is 24 hours. So basically, whatever is done, it's saved for 24 hours, and then it can be undone. So for example, we can drop and undrop a table. Let's imagine that we want to drop the JSON weather table. So we do the JSON weather data. So let's say we want to drop this table. And we see that the data was, the table was successfully dropped. Just to check that it was actually dropped, we can just do select from JSON weather data. And then let's say limit 10. And when we run this query, we should get an error because this does not exist anymore. This table does not exist anymore. Now, what if this was a mistake and we shouldn't have dropped this table? We can simply undrop this table by writing undrop instead of drop. And if we execute this statement, then it is successfully restored. So we have the data back again, and we don't need to worry about it and think that we've ruined the whole project. Another function is to roll back a table. So what the role bucket table does is it can fix an unintentional DML error, which is also very useful because maybe whilst working you made a mistake. So for example, let's imagine that by mistake we called every station name, the starting station name, oops. So to do this, let's just create this error or this mistake. So first we need to make sure we're in the right context. So we are using the role of the system administrator. We are in the warehouse called compute WH. And we're in compute because we are using the Citibank again, and we are using the Citibank, sorry, not Citibank, use the database Citibank, and we are using the schema public. So we, again, execute this query. So we are in the right context. And let's imagine we are writing update the trips set start station name as oops by accident, obviously. It takes a bit of time because there are many of the start station. And then meanwhile, I'll just write how then to check sort of that we actually replaced it with oops or not. So we want to count rows as right. And we want to use the trips table to do this. Order by to stand and then limit 20. So let's see the first 20. Sorry. Yeah, so we see that actually we only get one type, which is the oops for every sort of station. So we updated all the start station names with the oops. Now, let's imagine that we need to sort of like scramble up normally, right? So we would have to like go back and then back up, we'll hope that we have a backup so we can just go back and forget this ever happened. But in the Snowflake, we can do the following thing. So we can go to this, we can set a new query ID. So we're setting the new query ID from the information history by session. And then what we can do is we can create or replace the table streets from this particular query that we just created. So we are going to press OK. And this goes back to sort of update, like goes back to history by session. So whatever it is that we did will be recreated sort of or rolled back. So now if we choose this one again, instead of oops, we have to see, yeah, we see like 20 different sort of like stations, and 20 because we limited the 20. So it's actually changed back what we had before, and now it's the same way again, like it was before. So the next section, so it's amazing because you're allowed to make a mistake, which is I think it's quite relieving to know. Though it shouldn't mean that you should make mistakes. So the next module, not the module, the next part of the module explores the role-based access controls, account usage, and account admin. So in this whole time, we've been using the system administrator role, which is given right over here. However, it doesn't mean that that's the only role that we have. So we can actually create new roles and we can switch the roles as part of our account. So for example, to be able to create the new roles, we have to be into the account admin role, not the system administrator. So we go and switch the role from here to we actually see that we have a new icon here, which is called account. And I can do this through here, as we just did, to switch the role, or you can just simply code use role account admin and change it very easily. So now we're using the account admin role, but from here. Here it's still the system administrator. So let me. So if I do this now, then we will see that the context is changed. So now we see the account admin when before it was the system admin. Now let's try to create the new sort of the new role. So we can do this by worksheet, using the worksheet. So let's say we want to create a role called junior DBA. And then we have to grant the role, grant some of the permissions to this role. So we want to grant role junior DBA to whom? So who are we giving this role? So here we need to specify the user. Now I'm just gonna include my user, but if it was somebody that I was giving this role to, I would just include their username, but I'm just gonna create mine now. So the statement was successful. The statement was executed successfully. And now if I want to use the role of junior DBA, I'll just put this in here. And when I execute the statement, I should see the role changing here. And indeed, it changed from system DBA or account manager, I don't remember, to the junior DBA. And now we work as the junior DBA. However, we didn't specify the permissions of this role. We didn't specify what this person has an access to. So now I'm in the role of the junior DBA. And if I go here and if I refresh this, actually, I don't see any of the tables or databases that I created before. This is as if it's a new user, just how we sign up from the very, very beginning. So it's this user doesn't have any access to the databases that I've created before, or to see the tables and the views that we've created before. So we want to give them the access to some of the things that we've done. So to do this, we just create the context, and now we give the access, the junior DBA role, to the databases, different databases that we created. To do this, we actually we have to go back to using the role of account admin. So only the account administrator is able to do this, to create roles and grant access to various roles. So we use the role of the account admin, and then we write grant usage. So we grant the junior DBA on database citybike. Each role we specify, this is junior. Oh God, sorry. Junior DBA. And another one as well. Let's we grant the usage to different database, which is the weather. And we execute this. It was successful. And now let's use the role of the junior DBA again. And now we see all of this. We see the databases, but we haven't given access to what's sort of inside the public. We just gave an access to the database. So we see the city bike and the weather, but we don't actually see what's happening inside. So in the account admin is actually very powerful, maybe the most powerful in terms of like accessing, giving sort of giving the things or access to this person. So as I said before, when we switch the role from here into the account admin, the new account icon appears here, which is not, for example, if we go to the system. Oh, sorry. The account icon is not here anymore. But then if we switch the role from here to account, we receive the account icon. And in this icon, we have information about our account. In particular, if we press this, what we see is we see the usage. So I can see that I have three. I can see that I have 3 warehouses. And for each of the warehouses, we can see how many credits were spent, when did this happen, who are the users, what are the roles. So we can see basically everything from the account admin icon, which is actually really helpful to make sure that you can manage your account and see sort of like what's happening. Now we go on to explore how the sharing and the data marketplace is actually used in the Snowflake. We can press this icon here, and we go back to the worksheet that we had before. So with the secure data sharing at Snowflake, there is only one copy of the data that lives in the data provider's account. The shared data is always live, real time, and immediately available to the consumers, which is very useful because your consumer or the end user is not missing out on anything new, and you don't have to go and update your data. The providers can establish revocable fine-grained access, and the data sharing is very simple and it is very safe. Rather than, for example, if you wanted to share the CSV file and you actually have to send it to someone, and then obviously that's one, it might not be safe, and then two, it will be large and time consuming. Whilst here you can just do this by a simple click, which is very nice actually and very useful. We know that as we started the Snowflake free trial account, the Snowflake sample data was already created over here. We have to verify, to be able to share the data, we need to verify that we're in the account, we're in the system account. So we have to make sure that we switched our role from here. So to see, basically, in other words, this icon. And then once we are here, we can go to the shares. And once we go to the share, we see this, ignore this one, shouldn't be here. Actually, this one, ignore this one. We should see the two cases. So we have account usage and we have the sample data. And this is inbound. So basically, inbound is it contains the account usage and the sample data. So this is your consumer this is what you have this is what we have in our account. But we can also create an outbound data. And so we can use the outbound button, and then we can we want to share it to someone else. This is when we go to the outbound. So for example, we go to the outbound, we create, and let's say we are going to give it a name. So we're going to call it trips share. So we are going to share our trips database. So we are choosing the city bike because the trips table is located in the city bike database, and we are doing city bike database public, and we are choosing the trips, and we're going to press apply. And then we are going to press create, and we have created the share. Usually we could add the consumers, so who is accessible, but in this particular case, we don't really have consumers. So we're just going to press done, and we've already created, and we have created the secure share of the trips table. And here we see information. So account admin is the owner. When did we do this? Which database? And then it is the type of the outbound share. The next so this is not only tables that we can share, by the way. We can share, for example, we can share the tables, we can share the views, we can share like different secure UDFs and many others. Now we are going to move into the data marketplace, which is right over here. And as I already stated here, we are able to explore some of the external data sets that are published by other people, other organizations, which is very, very helpful for our analysis. So we press the explore the Snowflake data marketplace, and we are redirected to our account credentials. We submit our name, username, and the password. And we are redirected to the marketplace page. So the first thing we need to do is we are only able to get access to the data if we are into the account administrator role. So we go here and we change the role from system administrator to account administrator. And then we are in the marketplace. So let's, for example, let's assume that we want to search the COVID related data. We press COVID and we choose the star schema data for the analysis. And this should say free get the data. But because I have already inquired this data and I have already included this data previously and I forgot to remove it, it shows me the query data. However, if I didn't have this data already, it would here instead of the query data would be get data. So now I'm just going to press the query data since I already have it. And I'm redirected to, so basically without this, we would have one additional step, which is simply pressing the get data, and then it shows how it creates a new database, and we press the get data, and then we get this step of query data, and we are redirected to this page, which is the same. So here we see that select, we are going to execute this sort of code. Oh, sorry. Yeah, so for example, we see to see like what is it and what examples here do we have here. So here we see, for example, the countries and the regions and the cases in this each country and region. Here again, we see how the history and the performance of this query. I ran it through the control and enter, but it can be run through this button up there as well. And then we go back to home, sort of, to the data. And here we see now the different databases. So we are into the databases, and these are the databases we have. City Bike, and then this, the COVID by 19 by star schema is the one that we're looking at. And here we see the details of this. So who is the provider, who is the account admin, and what is the title, and sort of when was this created, and where did it come from, basically. And I believe this is the end of this module, except if we wanted to forget everything we've done and we wanted to start sort of over and drop all of these databases that we've created, we can do so by going back to our work environment, going back to the worksheet. First things first, we always have to make sure that we are using the right context. So I will be using, we have to use the role of the account administrator. And we are going to use the data warehouse compute, warehouse, use database weather, and use schema public. We're going to execute this to make sure that we're in the right context. And then if we want to drop all the objects that we created in this particular video, we drop share if exists trips share. We are going to drop the database if exists. It's city bike. We have another database, which is weather. Drop warehouse if exists analytics warehouse, and we created a new role. So drop role if exists junior DBA. And everything was successfully dropped and finished. So this is the last step of this module. As for the module, I think it was very straightforward. It explains everything really well. So as for someone who was new to the Snowflake, everything was easily understandable, except a little mistake where it says that it doesn't matter which cloud provider you use, but actually it does. And you don't see, so for example, this COVID data that we just got for free in Azure, you have to request it. So it's not freely available. So except this little mistake, I feel like everything was very straightforward, very easily understandable, and nice and smooth just to go through. Thank you. Have a good day.